Alright, in this video we're going to look at a trigonometry problem where we're given a point, -1 root 3, which is on the terminal arm of an angle theta. We want to determine all the trigonometric ratios and the value of theta. I should actually have stated this. If theta is in between 2 pi and 0, which means one rotation in that first rotation on the Cartesian plane. So the first thing you're going to do is draw this angle. So the point -1 root 3 would be somewhere around here. You don't have to worry too much about the scale, you just have to really get the quadrant correct. So -1 root 3 would be in the second quadrant. So we've got a terminal arm here. Here's your terminal arm. The angle is going in this direction. So the right angle triangle, or the right triangle you're going to be looking at, is the one created by, so theta is here, but you're going to look at the related acute angle here. Okay, so the sides of this triangle, remember this is y, so this would be root 3, but x is -1. And then r, you have to figure that out using Pythagorean theorem. So you know r squared equals -1 squared, which is the x value, plus square root 3 squared. So you're going to get 1 plus 3 r squared, so r is equal to the square root of 4, which is 2. You don't have to worry about plus or minus 2 when you take the square root here because r is a length, so r is going to be equal to 2. Okay, so now the question states first, determine all the trig ratios. So the trig ratios are sine theta, which is by definition y over r, which we have. We know y is root 3, so you get root 3 over r, which we just figured out, is 2. So sine theta equals root 3 over 2. Let's do it over here. Cos theta is x over r. So by, what's right there, x is -1 and r is 2. So you get -1 over 2. And then tangent theta, is y over x. So y is root 3. So you get root 3 over -1, which is -root 3. So there are your three trig ratios. Now we're asked for the value of theta. So the way you figure out theta is you just have to do your inverse trig ratio. You're going to have to use your calculator. Your calculator can do the inverse trig functions for all these trig ratios. So you have 3 trig ratios. You could use any of them to get theta. One of them will actually give you a nicer, or get you the answer a little quicker. You have to do sine inverse of root 3 over 2. Or you could do theta equals cosine inverse of 1 over 2. Or you could do inverse tangent of root 3, negative root 3. Okay, so in order to figure these out, or this out, you're going to have to use a calculator. So here's the calculator that's on the computer. It's not exactly the same as the calculator you'd probably be using, but there's a couple of things. Still do it. So the first thing you want to do is, we are working in radians now. So if you want your answer to be given in radians, the calculator is going to give you an answer for theta. If you want that answer to be given in radians, you have to change the mode to radians. So on this computer calculator, there's just a button I just can click radians. On most calculators that you'd probably be using, you might see a button that says DRG, or it might say DEG, RAD, GRAD. You want to, however your calculator works, switch the mode so that it's in radians. Because if it's in degrees, then it's going to give you the degree measure and you want the radian measure. So in order to figure out the inverse sine of this number, the way this calculator works is I have to input the angle first. So I want the square root of 3, so I say 3 square root divided by 2, and that's equal to 0.86. So this here is equal to 0.86, and now I'm going to take the inverse sine. So I get the number theta is equal to, it was 1.047. I can do the same thing with cosine. So I'd do the same thing here. In cosine, I'm just taking the inverse cosine of 1/2. So inverse cosine, I get 1.047. Oh, there's my mistake. I didn't have a negative. It was inverse cosine of negative 1/2. So let me just fix that. So it was negative 1 divided by 2. And then I need to do the inverse cosine of that number, which is 2.094. 2.094, which is actually a different number than I got here. I'm going to talk about why that is. Only one is correct, and we're going to talk about which one is correct. Similar thing if I do tangent. So for tangent, I need square root of 3. That's a negative number. And I want to do the inverse tangent. So here I get negative 1.047. So what's interesting here is I got 3 different answers for theta. There's only one which is correct. So notice here from the picture, theta was clearly in the second quadrant. So one of these numbers is in the second quadrant, the other 2 aren't. To figure out which one of those numbers is in the second quadrant, just think about what the values here. Remember that half a rotation is pi, which would be 3.14, and a quarter of rotation is pi by 2, which is about half of that, so it's about 1.57. So the value of theta has to be between 1.57 and 3.14. So the only number which is between them is this one. So this must be the correct answer. It's 2.94. But what about these two? Why are these ones? Why did our calculator give us these answers if only this one's correct? And the reason for that is when we did this one, we did the sine inverse of root 3 over 2. There's actually 2 angles which have a sine ratio of root 3 over 2. There would be one in the first quadrant and one in the second quadrant. Right? Remember when we did this for the related acute angle, alpha, but if there's also the actual acute angle, right, in the first quadrant, which would have the same ratio of root 3 over 2. So the calculator doesn't know which one you want. Do you want the one in the first or the fourth quadrant? The calculator can only give you one answer. So sorry, the first or the second quadrant, which quadrant is the calculator going to give you? The easiest quadrant, which is the first quadrant. So the calculator will always give you the angle in the first quadrant if that's a possibility, which it is in this case. So this is not actually the theta. This is not theta. This is actually alpha. And you have to know from your picture that you have to go back now and figure out what was the true answer. What's the value of theta? And the way you would get theta is you would have to say, okay, I need pi minus alpha to give me theta. So if you took this answer, theta, and did pi minus alpha, which would be pi minus 1.047, you would get the answer to 0.094, which is the same as that one there. So you would get the correct answer as long as you know, you have to kind of figure out which answer the calculator is giving you and know if that's the correct one. This answer here, why didn't that happen with this one? Why did this one give us the correct answer? Well, it's because cosine is negative. In the first quadrant, cosine wouldn't have been negative. Cosine was negative in the second quadrant. It's also negative in the third quadrant. But the calculator is going to give you the easiest one possible. So it gives you the second quadrant rather than the third quadrant. So that's why you got the correct answer here. This one, it gave me a negative angle. Why did it do that? So again, remember, tangent was in the second quadrant. Theta was in the second quadrant. And tangent was a negative angle because y was positive. Y is a positive value, but x is a negative value. So tangent would be negative in this quadrant. Tangent is also negative in the fourth quadrant because there it's the opposite, where x is positive and y would be a negative number. And again, so there's an angle over here with the same tangent ratio. The calculator doesn't know if you want the angle in the second quadrant or the fourth quadrant. So which quadrant is the calculator going to give you the answer in? You might hope it would give you the second quadrant because that's smaller than the fourth quadrant. But what the calculator does is it gives you the sort of negative acute angle, which is negative 1.047. So you have to know that that's what the calculator is giving you. And the calculator, when you do inverse tangent of a negative value, always gives you the negative angle in the fourth quadrant. So you have to know how to get the correct answer, which would be to, so again, this is not theta, this is kind of your acute angle, but it's negative. You have to know in order to get theta, you would have to do pi minus the negative of this, or minus 1.047, which is 2.094. So you get the same answer. Like this is the correct answer, but you have to know how to use your calculator and know which angle the calculator is giving you and know which one you're looking for, and if it gives you the one you're not looking for, how to get it. So it's typically a similar process to this question, but it will always differ slightly depending which quadrant your angle is in. So it takes a little bit of practice to figure that out.